Now, every year when we do methods in the last few years, we always start with exercise 3A. That's the first exercise that we start off with. We go to quadratics, and that's really revising what you learnt in year 10. Towards the end of year 9 and year 10, you learnt quadratics, and you learnt how to expand, factorize, and that was the main part. The last 2 years, you've been learning to factorize, okay? So today's session and tomorrow's session, really, I'm just going to work with quadratics. I'm going to work with quadratics. I'm just going to make sure that you can factorize, you can expand. That's our own goal. I'll go through a bit of surds because I know with surds, a lot of students struggle simplifying surds, and that's why this exercise may seem hard, but it's not. Yeah. So the working solution for them is not that hard. All right. Finn, next time don't throw, just go past it to him because in case it pokes his eye, I get in trouble for it. All right, here we go. Exercise 3A, expanding quadratic equations. Let's have a look. Expanding brackets. Now, Trent. Expanding brackets, you got what we call the distributive law. This is the law that you learnt in year 8, and then in year 9, you expanded to this rule. Okay? I know it looks complicated, but all you were doing, remember back in year 8, is if you were expanding, you would then say the outside number 3 multiplied to x, and then 3 multiplied to negative 4, right? And it's the same thing when you have two brackets. You still do 3x multiplied to 2x, and then 3x multiplied to 3. And then you do with the second term as well, you say negative 6 times 2x, and negative 6 times 3, right? What I'm more interested at this point is not how to do it, because you would have practiced how to do that. See at 7, 8, 9, 10. I'm more interested why. Ian, what? Same thing. What? Get up, walk over there, pass the pencil, don't throw. Right. None of my classes, if you've been in my year 8 classes or anywhere before, I always had the 2 rules. You don't talk while I'm speaking, and 2, you don't throw. Yeah. Why? Because if you threw it and it hit him in the eye, it's not your fault, it's my fault. Yeah? I get in trouble for that. Your parents or his parents will look for me.
But he's a good soccer
I don't care. No, I don't care. No. What if he wasn't paying attention? If it goes through his eye, I get in trouble. So please, for everyone in this class, you're going to pass on and get out of your seat, burn some calories, get a 6-pack, walk to that mate, give it to them and go back, okay? Don't throw. I don't want throwing. If you throw, I want to warn you that's my first warning. Second one, I'll kick you out. Yeah? Yeah. All right, here we go. Now, my question is, why is it that we do 3 times the x and then 3 times the negative 4? Why is that? Because a lot of students forget this. A lot of students will write this answer back in year 8. You would write 3x and you minus 4. You forget that you also times the 4 by 3. And I think the reason why you forget is because you don't know what you're actually doing, is that you don't understand what that bracket actually means. Okay, so I want you to think about it. Why is it 3 times the x and then 3 times the negative 4? Why do we do that? So why is it like, because it's in the bracket, why do you times it? I don't understand. Why do you have to times them all? Just because I tell you to? Just because it looks like it? Why? What if I did it like this? What if I had 3 bracket x minus 4 on 2? Now what numbers do I multiply? Do I multiply to the x and the 4? Or the 2? How do I do that one? How does that one work now? Yasmin? On the top, yeah. You times the numerator by 3x and then 3, 4. But you see, I don't want you to guess this. You have to like figure out, well, why am I doing this? Why does it work? Why don't I times the 2? Why does it work that I don't times the 2, but I always have to times the numerator? Yeah? So this is what I want you to ask yourselves. When you say times, let's start off with this. What does 3 times 4 mean? I don't want the answer. We all know what 3 times 4 is. 12. What does 3 times 4 mean? Yeah, 3 groups of 4. That's what it actually is. Or you can think of it as 4 groups of 3. Yeah, so all I'm saying here is I can say I've got 4 groups of 3, or you can say I've got 3 groups of 4. What that means is this is a group of 3. I've got 3 here. I've got another 3. I've got another 3. I've got another 3. That makes sense why you say 3 times 4 is 12, because 3 plus 3 plus 3 plus 3. ends up being 12. It makes sense. One group of 3, you got 3 here, got another group, that's 6, and another group. So, why is it that when you multiply, you have to multiply the x and minus 4? Because it's the same thing. See, if you told me 3 groups of 4 looks like this. You got 4 plus 4 plus 4. That's 3 groups of 4. Then 3 groups of x minus 4. Actually, I'll do a plus so it doesn't confuse you. Just basically means the same thing. If you said 3 times 4 is 3 groups of 4. I've got 1 group and 2 groups, 3 groups. Then 3 groups of x plus 4 just means I have 3 groups of x plus 4. So if I write it down, so you see, if you write down 3 groups of x plus 4, this is one group. This is another group. That's 2 groups. That's 3 groups. See, I've got 3 groups now. I've got 1, 2, 3. Just like you wrote here. 1, 2, 3. Now if you read it, that makes a lot of sense why you say, I've got x plus x plus x. That's 3 groups of x, which is why you write 3 times x. So that makes sense, 3 groups of x. And over here, you've got 4 plus 4 plus 4. And you already told me 3 times 4, which is 3 groups of 4, is 4 plus 4 plus 4. That's why we do 3 times negative 4, because we've got 3 groups of negative 4. That's why it makes sense. Yeah? So that's why when we do distributive law, we multiply them, because that's what it means. When you write a bracket, you write a number outside it, you're just saying the same things there. Okay? And then from that idea, it expands to this same idea. You're saying now, it's the same idea, you're saying 3x groups of 2x and 3x groups of 3. But because you got a second term, it's the same idea. You got negative 6 groups of 2x and negative 6 groups of 3. Okay? And that's where that sort of rule comes about. And you can show it by breaking up a value into 2 values. Okay? And that's how that rule comes about. All right? But I just wanted to make sure that you understand why you have to multiply that second term. Okay? Because it happens very frequently when I correct the year 11 SATs. When you're expanding, the common mistake you guys do is that, you know what's the other common mistake? This one. If I gave you guys something like that, some of you will get this wrong. See, this is back into year 9 and year 10, perfect squares. Most of you would do this. Because you're so used to seeing 4 squared, you're like, oh yeah, 4 squared is 16. If I asked you to do this, what you would do is you say, square the 2 is 4, square the x, that's 4x squared, and then you say plus square the 4 is 16. So what you would say to me, the answer would be, is 4x squared plus 16. That's the common mistake that I see a lot of students do. Why is that? Why is that wrong? See, if I see a lot of students write this, 4x squared plus 16. That's the common mistake. Because a lot of you just think, oh yeah, a square, when I do 3 squared, I just square the 3. So when you see this, your natural inclination, just like you do here, you're like, there's 2 of them, I square both of them. Square the 4, square the 2x, and you write your answer there. What's wrong? Felix?
Aren't you meant to go bracket 2x plus 4 times bracket 2x plus 4?
Yes.
So you multiply the whole thing by itself.
Yeah. And that's coming back to this bracket here. See, your answer, if you wrote 4x squared plus 16, I'll show you why it's wrong. See, when you write 2x plus 4 squared, 2x plus 4 squared, that just means 2x plus 4 times 2x plus 4. Because when you multiply, that's what you're doing. 3 squared means 3 times 3. 4 squared means 4 times 4. So when you say 2x plus 4 squared, it just means 2x plus 4. It's 2x plus 4. And now you're back to this rule. Now if we expand that, what you see is the answer doesn't actually come to 4x squared plus 16 if you expand it. So we're going to use the rule here. The rule tells me I'm going to take a multiplied to c and a multiplied to d. So that's what I'm going to do. 2x multiplied to 2x. What's 2x times 2x? What do I get? 4x squared. So you were right. You do have a 4x squared. That's true. And then 2x times the 4. What does that give you? 8x. So you got plus 8x. Now you got the other term as well that you're going to work out. So you got 4 times the 2x. What does that give you? Another 8x. And then finally 4 times the 4, 16. You see, your answer should be 4x squared plus 16x plus 16. That's the correct answer. And a lot of students just get the only top and bottom. Now we'll do the first and second. You're right, it was square the first, square the last. You're right, 4x squared 16, yeah, it's there. A lot of students miss out on the middle. And why is that? It's because of your misconception from the very beginning in year 7 and 8, you only do 3 squared, so you do 3 squared, 9, 4 squared, 16. And so when I put 2 terms there, you naturally go, oh yeah, I'll make up my own rule. The rule must be square the first, square the last. Yeah, but it's not about making up rules, it's all about why does it work. That's why I always say, try to understand your maths, don't try to memorize it. Because when you memorize, these are the mistakes you make. Yeah, when you're expanding, you forget to multiply that. You're memorizing. You're doing the same mistakes over and over. It goes all the way to my year 12s. You guys aren't the only ones. My year 12s are still making those mistakes too. Yeah? So, what I want you to do today is, besides learning it and working with it, I want you to write it out. Write out the working solution. The way I do, when I do it for you guys, I don't skip my steps. I don't skip it because I want you to see how I think. Yeah? I write it out clearly. Vertical or equal signs are vertical. Every expansion I do, I write it down. Don't be lazy when you're working out. Write it down so that you avoid mistakes. Okay? Yeah.
What's the formula like x squared plus 2ab plus?
That's it. And that's the one we're going to learn too. Okay? So for today, let's do some expansions now. So, here we go. Same thing with the second one. We're now doing 2x multiplied to 2, and then 2x multiplied to negative 4x. That's what I have here. Okay, so I'm just saying, take 2x multiplied to 2, which is here, plus 2x multiplied to negative 4x, which is there. That gives you now 2x times 2, which is 4x, minus, because x times x is x squared, and 2 times negative 4 is negative 8. That's why I've got my answer there. Okay? Alright. And then the last one, same thing as the expansion. We're going to do first group times first, first times second, second times first, second times second. Okay? Here we go. Make sure to copy these notes down. Whoops. There you go. So this is the first part, exercise 3A. You're going to learn how to expand, make sure you expand correctly, lay it out. You don't have to do the first step I'm doing. I'm doing that so you can see. Okay, but I do want to see these steps. I do want to see that you do 3x times 2x is 6x squared. 3x times 3, you know that's 9x. Negative 6 times 2, that's negative 12x there. And the negative 6 times 3, negative 18. And then simplify. Okay? Alright, how are we with copying? We're good. Alright, let's go. Now, surds. Let's see how we do with surds. Copy those 2 rules if you're not familiar with surds. The one thing I normally tell students is, yes, surds, how you work with surds, treat it like an algebra, like you said, treat it like an x. You only, when you collect like terms, you collect all the x's together, you collect all the y's together. Same thing here, you're collecting all the surds together. So you multiply surds and you add surds. Numbers, you add the numbers. Okay, so in this example here, when you're multiplying surds, see here I've got 3 root 2 times 2 root 3. Numbers with numbers, surds with surds. So if I were to multiply this, I would say 3 times the 2 is the numbers with numbers. In the surds, I've got 2 and the 3 here, so that's 2 times 3. Okay, so surds with surds, numbers with numbers. That's why this gives me 6 root 6. Anyone confused by that? No? I'll do another one. I'll make up one now. Let's do 3 root 7 times negative 4 root x plus 1. What would you multiply for this example? What would you multiply? Yes, ma'am. 3 and negative 4, that's the first thing. Numbers with numbers, so I'm going to highlight it. Numbers with numbers, so you've got a 3. I'm going to minus 4. See, that's not in the surd. So numbers with numbers. 3 with a negative 4. So 3 times negative 4 is negative 12. That's good. Now let's work with the square roots. See, inside the square root, I've got a 7. I've got a 7. And I've got an x plus 1. You'll be multiplying surds with surds, numbers with numbers. Yeah, so in this case, what you're actually saying is you've got, I'm going to do it in green here. You're now saying 7 times x plus 1. Okay, that's going back to what you've learned so far in the first exercise, or the first slide. 7 times x plus 1. What does that give me? Can I please have, let's go with Ben. How do I expand 7 times x plus 1? What does that give me?
Well, 7 times x, 7 times plus 7.
Good. So you got negative 12 root, and you got 7 times the x, which is 7x, and then 7 times the 1, 7. Okay, so this would be my answer. Numbers on the outside, and the root 7x plus 7. Just out of curiosity, what are you doing with the negative 12 in between the square root? What's happening here? Am I adding, subtracting, multiplying, or dividing? What am I doing? I'm multiplying. Okay, so when you write 2 root 3, what that actually means is 2 times root 3. That's what I want you to understand. And remember, if you write 2 times root 3, what does that mean? It just means 2 groups of root 3, which just basically means root 3 plus root 3. Okay, that's why when you add, you can do this. See, root A plus another root A makes sense that you have 2 groups of root A. Okay, if you have root A plus root A plus root A plus root A 4 times, you say 4 times root A. Okay, so when you add, treat a root A like an x. See, if I gave you this, if I said, instead of root A plus root A, if I wrote x plus x, and I asked you, what was that equal to, you had no problems. You'll look at that and say, oh yeah, the answer is 2x. It's the same thing with square roots. If I gave you 3 root 7 plus 4 root 7 plus root 7 plus root 8, what you don't do is this. A lot of students do this too from year 10. Students would do, oh yeah, 3 plus 4 is 7, and then they go 7 plus 7 plus 7 plus 8. Yeah, which is 29. And they're like, okay, so the answer must be 7 root 29. No, that doesn't make sense because you have to understand, well, what does 3 root 7 mean? It means I've got 3 groups of root 7. Root 7 plus root 7 plus root 7. I've got another 4 groups of these, so root 7 plus root 7 plus root 7 plus root 7. And then I've got another root 7. So I've got 8 of them. I've got 8 of these root 7s plus a root 8. So my answer, it should be 8 root 7 plus root 8. Okay, because the root 7's treated like x's. See, if I changed it to x's, you had no problems. I did 3x plus 4x plus x plus y. You could do that. You had no problems. But why is the surds becomes tricky? Because they're not used to seeing surds. But it's the same thing. So if I treated a root 7 like an x, instead of writing 3 root 7, I'll write it 3x. That's a root 7, so it's 4x. That's a root 7, so I called it x. And then that's a root 8, that's different, so I wrote y. So 3x plus 4x plus x, we naturally knew the answer was 7x. You don't even question that. But as soon as I put surds in, I see students doing all over the place. They're like 3 plus 4, and then that's outside numbers, inside numbers, 7 plus 7 plus 7 plus 8. You're making up your own rules. Yeah, it doesn't make sense. If you just read what it is, it just means 3 groups of root 7. You write it all out. It makes a lot of sense. Yeah, so that's why I'm saying treat the square roots like as if it's an x. And that way you won't get confused when you're doing that. Okay? Any questions there? We're pretty happy with square roots. Makes a bit more sense. Yeah, so that's just a mistake I tend to see. I just want to make sure that is explained so that you don't do that same mistake there. Okay, so the answer should be 8 root 7 plus root 8. That's what I'm trying to say there. Okay? All right, now let's try. Let's do, not that one. Where is it again? All right, multiplication. Let's do this one now. I want you to go expand 3x minus root 2 times x plus root 2. So we're combining the 2 slides. First slide and second slide. I want you to expand this for me. You know what's interesting? In 2014, that was 4 years ago, I first taught in EBIS in that group there. And it's a group of accelerated students. And I thought, oh my God, first year, it must be really smart. So I came in, I prepared a whole year's worth of stuff to do, and they're all accelerated. I came in when the performance center, because this building wasn't built at the time. I walked in there, the first sheet I gave them was this. I gave it out. there was 65, or wait, no, that was first year, so there was 87 kids in that class at the Performance Center. I gave them this, and you know how many kids came to me and said, it's root 2 times root 2, 2. Okay? And that told me, I'm like, oh, on my first day of teaching EBIS that year, I was like, oh, maybe they're not as accelerated as I had thought. And I had literally out of 87 kids, probably about 68 of them had no idea how to explain this. And that says a lot about going through how many schools you go through, how many different schools you come. You come into one school, I'm just teaching you simple year 8, year 9 mathematics there. Just expanding, just a bit more, inserts in year 9. And a lot of students have troubles there. So I'm just saying, you know, the basic concepts aren't well taught, hence why students find it very difficult to do. So have a go with this one. See if you can do this. It's first day of 2014 of my first year 11 EBIS group. They couldn't do this one. I had to take it all back and teach them from the very ground up again. Having said that, in year 12 they did pretty well for year 9. The year after they did better. First year. I remember that really well. Here we go. Hopefully you did 3x times the x plus 3x times the root 2 plus negative root 2 times x and then negative root 2 times root 2. So if you simplify all that, 3x times x, we know it's 3x squared. That's a number. That's a surd. This doesn't have a surd. So when you multiply them, numbers with numbers, surd with surd. So in this case, it's just 3x with 2. Next one. That's a surd, and that's a number. So when you multiply them together, it becomes minus x root 2. Over here, on the other hand, this is a surd, that's a surd. So it'll be root of 2 times 2, the negative on the outside. Okay, so this is what it should look like. I'm going to write it out. This is what you should have. 3x times x, 3x squared. 3x times root 2 is 3x root 2. Negative root 2 times x is negative x root 2. Surd from surds, 2 and the 2 becomes 4, and we've got the minus root. Easy. But we all know root of 4 is 2. Okay? So next step. Now this is where a lot of students find it difficult. So they understand that minus 2, they understand 3x squared. How do I get this? What did I do? And this is where I was saying, remember, this is a root 2, this is a root 2. So I'm just saying, okay, I've got root 2's. How many of these root 2's do I have? I've got 3x of them. And I'm minusing another x. Numbers with numbers, surds with surds. So that's why I know when you write out 3x root 2 minus x root 2, I'm just saying 3x minus x is 2x of these root 2's. As a comparison, in case you're confused, what if I gave you 3 root 4, root 2, plus 2 root 2? So in that case there, you would say, I've got 3 of these root 2's, and I'm adding another 2 groups of these root 2's. So how many root 2's do I have? I've got 5. 3 plus 2 is 5. 5 root 2's. Here, same concept. How many of these root 2's do I have? I've got 3x. What am I minusing? 1x of these root 2's. So how many root 2's do I have? 3x minus x. I've got 2x of these root 2's. That's where the logic comes from. Okay? That's why I got that. Okay? And that's the common mistake that a lot of students do. Yep. Wait. Oh. Yes, we just normally write the x at the front.
Yeah, but like, is it alright if I write this?
Yeah, it's okay.
It's okay?
Yeah, it's okay. Just make sure it's not under the square root sign. Fantastic. Try that one now. Try it again. So I explained. Try to get this one correct. 5x times x minus 3 times the 2 root 2. Let's see if you can simplify this one. Okay, same idea.
Oh, I like this one.
Starting tomorrow, I'll do a quiz, and the quiz will be on exercise 3A, yeah? I'm doing quizzes every session.
Really like four different channels.
Well, I'm from Mal.
You're not placing that down. You're not placing that. What else placing it?
Simone, Felix, I'm assuming you guys have done this already.
That's do you know what's mean of face?
Oh, Sydney, sorry, not Simone. My bad. I said Simone, but I'm looking at Sydney. Yeah, Simone's over there. Where's she?
But what I would say
Yeah. Yeah. Sorry, it was Sydney and Felix and Ryan. All right, go. Check your answers.
Whoa.
Oh, wait, I'm missing something.
Yeah,
no, it really is just one time.
Is it not steep?
Here times. Coefficient x squared.
Is lane saturation. Are we meant to do that? Yeah. But what about if you wanted to do like
I understand. Let me explain this one actually. This is probably from your textbook, so depending on how they do it, I'm pretty sure they'll do it like this. If you had taken the root 2s and you did 10x minus 6 of these root 2s, that's okay, yeah? The reason why I'm writing it like this is because it gives you the quadratic. Because when you expand this, it's meant to give you a quadratic. So when you have a quadratic, it's ax squared plus bx plus c. So this has no x's. So what I've done in this step here, if you're confused, is I took out x as a common factor. See, this has an x, that has an x. So I took out the x as a common factor, and I've got -3 plus 10 root 2 left over. This is my b term. I know it doesn't look like a traditional one, but in specialists, you'll be doing this more often. Yeah? And so it's just to keep in mind when you're doing quadratics, it has ax squared plus a bx plus c. This has no x constants. Okay, so that's how it should look like in your textbook. So if you're wondering why, it's because they collected the x's together. Yeah. There we go. All right, we've got 10 minutes left. I think that's all. I'm gonna stop there in terms of expansion. You can work on exercise 3A. Next session, I'll be going through 3A again and 3B, factorizing, making sure you can do perfect expansion as well. Perfect squares expansion. Thank you for reminding me. All right, here we go. In the meantime, you can have a look at your sacks as well.
So, am I right? Can I have a check?
Yeah.
Before we go,
Wait, something went wrong.
So you just say huh?
So this is right. This is right. So you did 5x times x is correct. And then -3 times 2 root 2 is correct. Now 5x times that is 10 root 2x, that's correct. And then -3 times x is -3x, true. But now this is, you got negative of these 3 x's, and you got 10 root 2 of these x's. So, how many x's do you have? You've got 10 root 2 minus 3 of these x's. Not, you don't do 10 take away 3. You don't do that. That's why you got the 7 here, so that's wrong.
So what can I do with this?
You just leave it as 10 root 2 minus 3. That's it.
That's it?
Yeah, you can't do anything more. This is still 5x squared plus, and this is still minus 6 root 2.
Yeah, but we can subtract this one. You can subtract this one.
You can't.
Yeah, you can't.
No, because remember, you can only subtract if it was 10 root 2, take away 3 root 2. See, that means I've got 10 of these root 2s, and I'm minusing 3 of these root 2s.
7 root 2.
Then that makes sense that it's 7 root 2. But right now, if I don't have that, that doesn't make sense. Because this is just minus 3. This is 10 of these root 2s.
So basically, I factorize it.
Yeah.
Alright, let's go. Sink water. Charlotte.
Actually, okay.
Yes,
I really don't want to
Matt over here. It's out of 30, so add your total mark down here and divide it out. Such as happens.
You're 73 again.
Oh, yeah, this is how we get additions. Rachel. And you know what? I think we need communism. Anna.
If we could share our
We'll be going through this on Wednesday, yeah? When you come in, I'll explain.